Hello, I am Taylor, and today we're going to be evaluating some functions. So here we have q of x equals 1 over x squared minus 9, and we are going to plug in q of 0, q of 3, and q of y plus 3. Now, the q of these numbers is the same as the q of x, but we're putting in a variable for it. So we're going to do q of 0 equals 1 over 0 squared minus 9. See how I plugged in the variable for the x? And after I evaluate that, that's 1 over 0 squared is 0, minus 9 is negative 9, and we combine the fraction, and we have negative 1 over 9ths. Next, we're going to plug in q of 3. So q of 3 equals 1 over x squared minus 9. And again, I plugged in the 3 for the variable, which I'm going to do now. 1 over 3 squared minus 9. And 3 squared is 9, so 1 over 9 minus 9 equals 1 over 0, which is undefined, sadly. And last but not least, we have q of y plus 3, so I'm going to plug that in. Q of y plus 3 equals 1 over y plus 3 squared minus 9. So I'm going to do a little bit of factorization here. This is more a bit of a complicated problem. So we're going to do y plus 3 times y plus 3, and I'm going to factor it all out. Y times the y squared, y times the 3, plus 3y, another 3 times the y, I got to do ins and outs. So that'll be plus 3y, and then 3y, and then outers, plus 9. So I have 1 over y2, combine these two into 6y plus 9 minus 9. And these two 9's cancel out, so I am left with 1 over y squared plus 6y equals q of y plus 3. And that will conclude our go.
Alright. Hi, I'm Dakota. We're going to be doing evaluating some functions. So right now we've got our equation f of x equals x squared minus 2x. So right now we're going to plug it into our first number here. This is going to replace our x since x is our variable, so we're going to get f of 2 equals, we're subbing in that 2 for the x, squared minus 2 times 2. So now we're going to get equals 4 minus 4. Now these two 4's cancel out, so we're going to get 0. That's our final answer. Now here we're going to move on to f of 1.5. So f of 1.5 equals, we're going to put that 1.5 in for x. So 1.5 squared minus 2 times 1.5. So we're going to get a 2.25 minus a 3. Now those two are going to equal out. Not equal out, but subtract, and we're going to get a negative 0.75. Or you could also write it as the fraction negative 3/4. And finally, we're going to move on to our final problem. We've got f of x plus 2, this is going to be a fun one, equals x plus 2 squared minus 2 times x plus 2. So we've got to, since this is squared, now we're going to, first our outer terms, x squared, now our x's. Now we're going to do x, so we got 2x. Now this is going to equal another plus 2x, and finally we're going to round it off with a 4. So these are going to combine. So we've got x squared plus 4x plus 4. Now we're going to distribute our 2 here, so we've got 2x, and distribute the 2 here, plus 4, all subtracting. So we're doing plus 4 subtracted by 2x minus 4. Since this minus is like having a negative 1, so you've got to distribute through there. So now we're going to I guess simplify our problem here. We've got x squared. These two x's are going to subtract from each other, so we're going to have plus 2x. And these two 4's are going to cancel out, so that's going to be our final.
Here we go. This is Taylor Robinson again. Here we're going to go over some common mistakes made when evaluating functions. So here we have h of x equals x to the 4th minus 2x to the third plus 16x squared plus 8. And here's our variant h of 1/5. Now what you want to do is plug in h of a fifth for all the x variables, obviously. So let's just get this set up so we can get a nice fat look at this. Now, obviously when we want to do what the functions say and distribute everything to its proper place. So a common mistake that people make is that a fifth to the fourth means that you multiply it by 4, or even just do the numerator, since people want most often want to assume that that's just a number taken at multiplied times, but it's not. And there's one of two things that you could do here. You could either just put it into your calculator, or if you don't have one handy, you could do a fifth times a fifth times a fifth times a fifth. And that's the most simple way to do it if you're just starting off basic, so we'll do it that way. So that'll be 25 times another 5. That'll be 125 times another 5. That'll be 575. So 1 over 5 minus 2 times 1 to the fifth to the third. Now what you can do is you already did most of the work, so you just take that times that, which is 25, and add another one, so we get just the first 3, 125. So that'll be 1 over 125 times 2 over 1, so it'll be 2 over 125. There we go. So minus 2 over 125 plus 16 times a fifth. So we have 16 over 1 times 1 over 5. Multiply. Can't simplify anymore, so 16 over 5 plus 8. And some people also want to just leave it in this form and say that's the answer, but that's not. You have to get a common denominator between all of these. And what you can do here is you can take that times 5. We'll just have the common denominator is 575, so take that times another 5. So what you do to the bottom, you have to do to the top, and some people just want to stop and only do it to the bottom. So 1 over 575 minus times 5, 10 over 575 plus 16 over 5. So we know that 125 times 5 is 575, so we'll take that times 125 on the top and bottom. So now we have 1 over 575 minus 10 over 575 plus 16 . So that then gives us an even 2,000. And then plus 8 over 1, so now I have to just take that times 575. So 575 times 8